Hello guys, welcome to my YouTube channel. In this video we are going to learn how to create or draw a 1-bit ALU, which is an arithmetic logic unit on Logisim. Now the 1-bit ALU, since it is 1 bit, it will be receiving 2 inputs, and the arithmetic logic unit will tell, based on the input of 2 selectors, which logic operation it should use on the 2 inputs. So for example, no, it's not even an example, it's this truth table. If the selector's value is 0 0, meaning the 2 inputs should be AND. If it is 0 1, meaning the 2 inputs should be OR. If it is 1 0, meaning the 2 inputs should be NOT. And if it is 1 1, the 2 inputs should be added. So for example, if you have 2 inputs, which is 1 0, and the selector's input of the arithmetic logic unit is 0 0, its output will obviously be 0, because 1 and 0 is 0, and output 1 only when the 2 inputs are 1. Now at the end of this video you'll get what I'm trying to say. Now let's get to business. So in order to draw our first arithmetic logic unit, let's get our AND gates. We need one AND gate here, and we will need another OR gate to come somewhere here, an inverter to come here, we need an XOR. When you come to gates here, click on exclusive OR gates. We will need an exclusive OR gate. Should sit somewhere here. We will need another exclusive OR gate. Should be somewhere here. We also need 2 AND gates, which should sit somewhere here. Another AND gate here. 1 OR gate here. Yes. Another 2 we also need 2 inverters. One will obviously come somewhere here. Another inverter will come here. We will need 4 AND gates, which will act as the multiplexer. one here, AND gate which we use to design the multiplexer, another one too here, another AND gate here, another AND gate here. Now one big OR gate. Stand as the output. Let's give it one output value here. Here too there will be a carry out. Okay. So here is where we will get our logic operations. Here is our full adder, and here is our multiplexer. Don't worry, at the end of this video you will get what I'm trying to say. So let's put one input here, another input. We will need another input variable. We need another input. We need another input here. We also need another. We already have an output here. We need an input for the two selectors, which will determine which kind of operation it should use. So one input will be here, and lastly another input will be here. Now selector inputs. Now these are the components we will need. These are the logic gates, inputs and outputs we will need. Now it's left with wiring. But first of all, you have to change their input values, the number of inputs. This is receiving 3, this is having 3 inputs, this is also having 3 inputs. Exclusive OR gate, this is also having, sorry, the exclusive OR gate, all of them are having 2 inputs, rather 2 inputs, all of them are having 2 inputs, rather not 3. 2 inputs, 2 inputs, so having a 2 inputs, yes, 2 inputs for this one, 2 inputs for this one also, 2 inputs for this one also. For these ones. Now these ones will take 3 inputs. Remember the multiplexer we did in the previous video, how the multiplexer was, yes, the 3, the 4 AND gates used. We're having 3 inputs each. Another one input will come here. Now this will be receiving 4 inputs from the AND gates. Now let's do the wiring. First of all, let's also change the positions. It should face southwards. In order for the wiring to be possible, this one should also face southwards. Yes. No. This should face southwards also. This should face southwards. Let's shift this one backwards a bit. Let's shift this one too backwards a bit. Okay. Now let's do the wiring. We've made sure each of the logic gates are having their correct input values. Now let's connect this input straight. Connected to this output. Yes. Another one to straight up here. Oh no. Oh shit. Let's delete it. It's coming straight up. Yes. Connect it to the output. Now we're left with the design of the multiplexer. We've designed our full adder here. Now it's supposed to connect values. Connect this one also. let's connect the inverters also to the selector input. We'll connect this one also here. Now connect the this one to the signal here based on the circuit. Now first do some connections. Come here. There's another one too here. Takes this input, this one takes this input, this one takes this input. Now let's do the connection of these ones together. Output here, error. Now let's label the input. So this is our multiplexer. This is our multiplexer. This is the logic gate and or not other. Now let's label our input here. Let's put it on not. Let's take the input A. Let's label this input B. Let the label's location be not B. Let's label these ones so let's select test S1. Let's label this one S2. S2. Let's label the output of the other Y. Y0. Let's label the output of the multiplexer Y1. There's one input here. Let's label it. So this is serve as an enabler. So let's label it E. Now we are done. Let's see how it works. So guys, remember I told you that when the selector values, these are the selector values, 0 0, meaning these two inputs will be AND, that is this and this. The output will come. If it is 0 1, it will be odd. A odd input A odd to input B. We have the notes. If it is 1 0, if this input is 1 0, A not B. And addition. So for other, where here is 1 and here is 1, what happens? The addition of this and this. So let's experiment first. It is 0 0. So which tells us that the AND logic operation or AND logic operator is now working. So in order for the AND to output a value of 1, the input should be 1 and this input should also be 1, which you can see clearly. That this output here is on. Now let's off it. Let's off 1 0, which is off, because AND for two inputs, its table should be 1 1 in order to output 1. Now if it is 0 1, the OR gate is working. So if it is 1, so this is what should be working. Okay, now let's first of all check something here. This is 1 1, both the selector value and the summation have come. Now let's check if the inputs are 1 1 1. 1 1 stands for addition. 1 1. So the other here has this one. If it is 1 0, it asks them to give an output of 1. Now let's check for the OR. So this is currently what is happening now. Yeah, so okay guys, so realize that the OR gate here, since here is 0 1, the OR gate is not working because the input 1, this one 1 0 should output a 1, but it's not working, which shows that there is a mistake somewhere. Yes, I've gotten it. Here, the inverter here, this wiring, I miswired it. In a complex circuit like this, need patience. Rather, it should rather come. It should rather come here. Whilst this one. Oh shit. This one should rather come here. This wiring. Now let's delete this one first. This wiring of the S1 should come here. Where's this wiring? Comes here like this. So first of all, let's turn it off. Now let's bring it straight forward down here. Complex circuits like this need patience. Now let's check the OR gate again. Now let's start all over because we've made some changes to it. First of all, if the input is 0 0, the end operation is working, which has come. And if it is 0 1, is 0. Now let's move to OR. If it is 0 1, it's the OR operation that is working now. So 1 1, it has been outputted. 1 0, the same 1 has been outputted. 0 0, here is off. Now if the selector input is whether 1 0, it will output the NOT of the two values. So here is 0 0, and here the selector input is 1 0, telling us that the NOT operation is now working, or the NOT logic operator is working. So the input 0 0 outputs 1, and the input 1 1 obviously output 0 here. You get it? Yes. Now let's come to the last one, which is 1 1. That's the addition as 1 1, or some people call it the sum. So if the input value is 1 1, the output is 1 1 0 1. 1 is here, 1 plus 0 is 1, but the multiplexer outputs 0, low voltage, 0 0 0 0 1 1 0, less 1 1 before auto outputs 1. So guys, this is a 1-bit ALU. That's a 1-bit arithmetic logic unit. When we say 1 bit, it means it's receiving 2 inputs. Now, so right now, based on the inputs and of the selector, it tells which operation or which logic operator it should work on the 2 inputs coming in. So guys, I hope you really understand it. And complex, circuit like this needs patience, and painstaking attention in order to get it right. So as you are practicing it at home, make sure you do the wiring correctly. Like the mistake I just made by changing the wire of these two inverters here, which made the OR gate not work. Yes. So thank you for watching this video. I would like to hear from you in the comment section. Don't forget to like and subscribe. Thank you. Bye bye.